rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Hello students, welcome to this video lecture. Here we are going to discuss mathematics for IIT-JEE Main and Advanced by ML Khanna sir. This is S. Chand Academy, the official YouTube channel of S. Chand Publishing, and I am Subuh Nadeem, who is introducing you to this book through videos. So, if we talk about the chapters here are of coordinate geometry, parabola, ellipse, hyperbola, coordinate geometry of 3 dimensions as the 4 topics of coordinate geometry. This is volume 2 of the book. Volume 1 was already discussed. Then we have vectors, and there are few chapters: integral calculus, differential calculus, and then we have statistics and algebra. These topics are there. So the chapter which we are going to discuss in this video lecture is parabola, which is chapter number 20. Now first we will introduce you to the few important concepts of parabola, then we will start few questions from the book itself. So first of all, what is a definition of a parabola? If we take a point and we take a line, and if we take another point in the plane such that the distance of this point from this point and distance from this line is equal. So what we are talking about is as the focus, which is the fixed point, and this point is the variable point, which we are saying is suppose x comma y, and we are taking this line as the directrix. So if we are saying that this is the directrix, then can we find the equation of this parabola by saying that PS by PM is equal to 1. So what is S? S is this focus, and what is directrix? This is this line, and PM is the perpendicular from P on this directrix. This is PM, and this is the distance from P to the focus S. Now we are saying that this length is equal to this length. Now if we are saying that these two lengths are equal, it means that this is having eccentricity is equal to 1. This is the definition of the parabola. As we know that all the conic sections have different eccentricities, so parabola has a eccentricity equal to 1. Now if we suppose this focus is a comma 0, and this directrix is x is equal to minus a, and then we have the y-axis, this one, and this we will have the x-axis, this one, and then we want to find the equation of this parabola. So distance of x from focus we say as x minus a whole square plus y square under root, and distance of this P from directrix is equal to x plus a mod. Now when you will square both the sides and simplify, you will get an equation called y square is equal to 4ax. So this will be a curve which will be something like this. A curve, this is the curve, and this is y square is equal to 4x. So this is the geometrical representation of this equation, y square is equal to 4ax. As you can see, this is symmetric about the x-axis, and there is a point here which is the origin. It is called the vertex of the parabola here. So this is 0 comma 0, and this is the vertex of the parabola. This line is called directrix, and this y-axis is called the tangent at the origin of the parabola, or tangent at vertex of the parabola. And there is another term which is called latus rectum. So if a line or a chord which is perpendicular to this axis of the parabola, which is x-axis here, is called the latus rectum here, and this is actually cutting the parabola at 2 points. One point is a comma 2a, another point is a comma minus 2a. So length of this latus rectum is equal to 4a. So these are the main basic terms which we have. Another is the focal chord. Focal chord is any chord which is passing through the focus. And very important point is there about focal chord. The point says that if there is a parabola and we are taking the focal chord here passing through the focus S a comma 0, and this is the parabola y square is equal to 4ax. Then we have this as the parametric point as a t1 square comma 2a t1, because it automatically satisfies this equation of the parabola, and this is a t2 square comma 2a t2. This also automatically satisfies the equation of the parabola. So t1 t2 are the parameters of these 2 points here. One point is a, another point is b. So if it is a focal chord, then t1 t2 is equal to -1. This is what we have to know about the focal chord. We can easily prove this result, but we are not going into the derivation. In book, of course, you will find many more results which are interesting. So here it is an introduction basically. Now, if we talk about tangent to a parabola at a particular point, suppose x1 comma y1 is the point, and you have to find the equation of tangent to the parabola, then that is t is equal to 0. Now what is t basically here? So t is equal to y1 minus 2a x plus x1 is equal to 0, because what we do that in the equation 1y is replaced by y1 and 2x is replaced by x plus x1. And if we take this point as a parametric point at square comma 2at, then this equation becomes ty is equal to x plus at square. You can just replace x1 by at square and y1 by 2at and you will get this result. What happens that if you see the slope of tangent, if you are talking about, then slope of tangent will be equal to 1 by t. As you can see from this equation, it will be 1 by t. And if you talk about the slope of normal, so what will happen to slope of normal? We know that slope of normal is reciprocal and opposite sign of slope of tangent. So this will be minus 1 by t. So this is the normal here, and this is the tangent here. So these are the equation of tangent and the condition of the relation between the tangent and the parameter and the slope of the normal and the parameter. Next, what we have to understand here is that there is a result about chord of contact. If we take a point P which is outside the parabola and it is x1 comma y1, then what is a chord of contact? If you draw two tangents to this parabola from this external point, and if you join these 2 points of contact, this is called chord of contact. And chord of contact is having equation P is equal to 0 again. The only difference is that there the point in case of tangent was on the parabola, here the point is outside the parabola. So same t equal to 0 can represent the equation of a tangent if the point is on the parabola, and same t equal to 0 can represent the equation of the chord of contact if point is outside the parabola. Now we have to also study if there is a chord and its midpoint is given. So I am drawing in the same diagram here. So this is a chord and its midpoint is given x1 comma y1, and then it is asked what is the equation of this chord. So the equation of this particular chord is t is equal to s1, as the chord of contact was t is equal to 0 if this was the point. So I am taking the point q here. Let us suppose this is x1 dash y1 dash. So this is the point. So what is t is equal to s1? It will be y1 dash minus 2a x plus x1 dash is equal to s1 will be y1 square, that is y1 dash square minus 4a x1 dash. So this will be s1, that is just replacing x1 dash y1 dash to the equation of the parabola y square minus 4ax. So this is the equation of this chord. So we have two results. One is chord of contact, and that chord of contact is t is equal to 0. Another result is we have that chord with midpoint x1 y1. So if you take a chord with midpoint x1 y1, then that equation will be t is equal to s1. So this is having two equations which are very important for a tangent. Further, we can talk some more things about parabola. So we have basically a shifted parabola also. So if a parabola is like this and we are saying that we have shifted it somewhere or translated its axis to somewhere, keeping x and y axis parallel to the new axis of the parabola and tangent at vertex to the parabola. So this will be the new tangent at vertex to the parabola and this will be the new axis of the parabola. This was the origin, which was old vertex. This is h comma k. So this equation will be y minus k whole square is equal to 4ax minus h. Now equation of the parabola is not only this. Equation of the parabola can be others also, like if it is an upward opening parabola. So if it is an upward opening parabola, what will happen? It will be x square is equal to 4ay. What will happen if it is a downward opening parabola? Then this will be equal to x square is equal to minus 4ay. Okay. If it is a left opening parabola, what will happen? Y square is equal to minus 4ax. So basically the focus here is now minus a comma 0. So this is how we take the different cases here. Now if we come to the question of the parabola, so the first question says find the equation of the parabola whose vertex and focus lie on the axis of x at distance a and a1 from the origin respectively. So this is problem set 1, question 3a. As you can see from the book, is a very important question for starting a conceptual topic like this. So we have given that the axis focus lie on the axis of x at distance a1 and vertex at distance a. So vertex is at this point, which is a comma 0, and the focus lie on the axis of x at distance a1. Focus is at a1 comma 0. This is also represented by S. You can use F or S. Mostly we use S for focus. Now how can you say that what is the equation of this parabola? So first of all, you have to understand here what is happening. Here actually, this is the focus which is at a distance a1 minus a from the vertex. So this is the distance. Now it is also saying that you have to find the equation of the parabola. So this will be a parabola which may be going like this. So vertex is a comma 0. Originally the equation is y square is equal to 4ax. Now it is shifted. Where it is shifted? It is shifted to a comma 0. So this will become y minus 0 whole square is equal to 4 and x will be x minus a. Now what will be a? A was actually the distance between the focus and the vertex. So as we were seeing that we have this point as vertex as a comma 0 and this point focus as a1 comma 0. So this distance is a1 minus 0. a1 minus a. Now distance between the focus and the vertex is actually the a where we have written y square is equal to 4ax. If you remember this, then we have y square is equal to 4ax like this. And a comma 0 is here. This is the point and vertex is here. So distance between vertex and focus is a. Now here the distance between focus and vertex is a1 minus a. As it is saying, find the equation of the parabola whose vertex and focus lie on the axis of x at distance a and a1 from the origin respectively. So this will become y minus 0 whole square is equal to 4 and this will become a1 minus a into x will be x minus a, because x coordinate of the vertex is a, so it has got shifted. So finally it will be y square is equal to 4 a1 minus a into x minus a like this. So this is how we can write the equation of this parabola. So the situation could be different also if we would have taken the focus on the left. We have a situation like this, that focus vertex is at distance A here, and focus is at distance A1, and we will put a minus sign because it is on the left side. So then also you can find a parabola, and this would be like this. So you can do it on your own also and find it out. Next question, let us move on. Equation of the parabola whose axis is y is equal to x, distance from origin to vertex is root 2, and distance from origin to focus is 2 root 2 is. And it is given that focus and vertex lie in first quadrant. So what is given is basically that there is a line y is equal to x. This is the line y is equal to x, and this is the axis, and origin to vertex is root 2. So this is origin and this is the vertex, and the distance is root 2. When the distance will be root 2, as we know, we can take vertex as 1, 1, then OB will be root 2, and the distance from origin to focus is 2 root 2. Now I am taking focus, and focus coordinate will be 2, 2. Then only the distance OS will be root over 4 plus 4, 8, that is 2 root 2. And then we draw the parabola like this. So this is the parabola, and from, as we can see, that the distance is root 2 here also and root 2 here also. So directrix is this one. Y is equal to minus x is the directrix, and y is equal to x is the axis of the parabola. Now we can just apply the definition of the parabola. What is the definition of the parabola, students? That is the distance of a point on the parabola to focus is equal to distance of the point on the parabola to the directrix. So if we take a point x comma y here, and we take the distance from focus, so it will be x minus 2 whole square plus y minus 2 whole square is equal to its distance from the directrix, that is x plus y mod by root 2, and we will take a square root here. Now we have to solve it. So let us solve it. This will become, after squaring, x square plus y square, and this will become minus 4x minus 4y plus 4 is plus 8, and this 2 will come here, and on the right hand side it will be x square plus y square plus 2xy, like this. Now in the next step it will become x square plus y square after subtracting, and then we will have minus 2xy, and then we have minus 8x minus 8y, and then we have plus 16 equal to 0. Now this will become x minus y whole square, and there it will become 8 times x plus y minus 2. So option B is the correct option. Let us come to the next question. Next question says, find the equation to the common tangent to the parabolas y square equal to 2x and x square equal to 16y. So if we are talking about a parabola which is y square is equal to 2x, and another parabola which is upward opening parabola, and it is x square equal to 16y, and we find the common tangent, then that common tangent will be this one. Now if its slope is m, so this is y is equal to mx plus a by m. What is a? So from right opening, here a is equal to half, as we see 4ax, so a is equal to half. So we can say that it is y is equal to mx plus 1 by 2m is the equation of the tangent. Same equation is for tangent of x square equal to 16y, so it will satisfy it. So x square is equal to 16y. but since it is a quadratic in x and it will have only one solution. Why it will have one solution, students? Because its discriminant will be 0. And why its discriminant will be 0 and it has one solution? The reason being that it is a tangent, so it will touch it at only one point, no two distinct solutions. Otherwise it will become a secant. So this will become x square minus, you can take minus 16 mx minus 8 by m is equal to 0. So this will become like this. Now this is nothing. Now its discriminant is b square, which is 16 square m square minus 4ac, so 32 by m, and this should be equal to 0. So you will write m cube plus 1 by 8 equal to 0, of course. After calculation you can easily see this is m cube plus 1 by 8 equal to 0. So m cube is equal to minus 1 by 8, so m is equal to minus 1 by 2. So this is the slope. Now the equation of the tangent will be, you just replace m is equal to minus 1 by 2 here and you will get the answer. Let us come to the next question. This says, to the vertex O of the parabola y square equal to 4ax, a perpendicular is drawn to any tangent meeting in it at P and the parabola at Q. Show that OP into OQ is equal to constant. So what is given here is, basically, there is a parabola y square is equal to 4ax, which is a right opening standard parabola. A perpendicular is drawn to any tangent meeting it at P. So there is a perpendicular drawn to any tangent meeting it at P and the parabola at Q. So this would be something like this, right? So this is the vertex, this is the perpendicular on tangent, so this is the point P, and again it is meeting at the parabola Q. So that OP into OQ is equal to constant. So we can take the equation of the parabola as Ty is equation of the tangent, sorry, Ty is equal to x plus at square. Now this is the equation of the tangent. Now what will be the slope of this perpendicular line? This slope will be equal to minus t, just reciprocal and negative of the slope of the tangent. Now we can find this equation. So this equation will be y by x, as it is passing from origin, is equal to, slope is equal to minus t. So this is minus t. So this will become y is equal to minus tx. So this slope is equal to minus t. So this is y is equal to minus tx. Now when we solve these two equations, this one and this one, what will we get is that y is equal to minus tx, so this is minus t square x, and this will become 1 plus t square x is equal to minus at square. So you will get the x coordinate here. So x coordinate would be minus at square by 1 plus t square. And what will be the y coordinate? Minus tx, so a t cube by 1 plus t square. Now also you have to solve with y square is equal to 4ax to get the point q. So when you solve with this, y is equal to minus tx, so t square x square. So t square x square is equal to 4ax. So from here x will be equal to 4a by t square, and y will be equal to, so y will be equal to minus tx, so minus 4a by t. So this is the y coordinate. Now you find the length OP. So when you find the length OP, that length will be this length from origin. So as we know x also and we know y also, 1 by t square will come outside, and in fact a t square will also come outside, and we will get a t square by 1 plus t square, and we will get t square plus 1 under root. So we will get under root 1 plus t square finally as OQ. Now if we talk about OQ, what will be OQ? OQ will be, this is 4a by t square, this is 4a by t. So you will get 4a by t outside, and what will happen? 1 by t square plus 1, that is root over 1 plus t square, and there will be t in the denominator. So this will be t square root over 1 plus t square, like this. Now if you find OP into OQ, so what will happen to OP into OQ? As you can see, OP is a t square by root over 1 plus t square, and OQ is 4a by t square into root over 1 plus t square. So t square will get cancelled and root over 1 plus t square will cancel, and you will get 4a square. So this is independent of t, which is a constant for a given parabola for y square is equal to 4x. This is what we have to prove. So now the next question is, it says show that lattice rectum of a parabola bisects the angle between the tangent and normal at either extremity. So if we take a situation of a right opening standard parabola, y square is equal to 4ax, and then we draw the lattice rectum, x is equal to a, then we have the normal, this one, and the tangent, this one. Now if we take the parametric point t, then this angle theta, which is the slope of the tangent, tan theta, is equal to 1 by t. This is the slope of the tangent, right? And if we talk about the slope of the normal, this mn, then this will be equal to tan alpha. And what is alpha basically here is, so alpha is this angle, and tan alpha will be equal to minus t. Now if we take the angle, this as A and this as B, so this angle tan A is actually equal to, tan of A is actually equal to 90 degree minus theta. So this will be tan 90 degree minus theta, which will be cot theta, and cot theta will be equal to 1 by tan theta. So that will be t, right? So this is tan A. So A is tan inverse of t, you can say. And then we talk about tan B. So tan B is equal to tan of, if we talk about the angle alpha, then alpha minus 90 degree is B. Okay, exterior angle property of a triangle. So a beta B plus 90 is alpha. So alpha minus 90 is B. So tan alpha minus 90 is minus of tan 90 minus alpha, which is cot alpha. So minus cot alpha. Now what is cot alpha? That is actually minus 1 by t. So this will become 1 by t. So tan A is t and tan B is 1 by t. Now this point T is actually that the lattice rectum extremity. So this point is having value 1, because as we know that extremity is a comma 2a. So if we take y square is equal to 4ax, then there at square comma 2at will have t equal to 1. So finally t is equal to 1 if we take this t is equal to 1, and this will be also 1. So we can say that tan A and tan B are same, that is A is equal to B. Now let us come to the next question. It says prove that the circle drawn on any focal chord of a parabola as diameter touches the directrix. So it says that we have a parabola and there is a focal chord passing through a comma 0. Its extremity is T1 parametric point and T2 parametric point. And taking this as a diameter, we are drawing a circle. Now this circle is touching the directrix. This is what we have to prove. That is x is equal to minus a. So what will happen? First we write the equation of the circle in diametric form. So x minus a t1 square into x minus a t2 square plus y minus 2a t1 into y minus 2a t2 equal to 0. Now this is the equation. Now what happens? X equal to minus a I am replacing here. So if x is equal to minus a, this will become minus a 1 plus t1 square, and this will be minus a, so this will be a square 1 plus t2 square, plus this will become y minus 2a t1 into y minus 2a t2 equal to 0. Now we have t1 into t2 is equal to minus 1, as it is a focal chord, that we know. So when you multiply a square 1 plus t1 square plus t2 square, so 1 plus t1 square plus t2 square plus t1 square t2 square will be 1 again, like this, and here it will become y square and plus 4a square. T1 t2 is minus 1, so this will be minus now, it will not be plus, this will be minus, and this will become minus 2a t1 plus t2 into y equal to 0. Now we can write y square minus 2a t1 minus 1 by t1 like this into y, and then we have minus 4a square and then plus 2a square is minus 2a square, and t2 is equal to minus 1 by t1. So t1 square plus 1 by t1 square minus 2a square. So we can write it as a square common, and it will become a formula of t1 minus 1 by t1 whole square equal to 0. This is what we are getting. Now this is becoming a perfect square. That is y minus a t1 minus 1 by t1 whole square equal to 0, as you can see. Y square minus 2ay t1 minus 1 by t1 plus a square t1 minus 1 by t1 whole square. So clearly this is giving a single value of y because there are repeated roots. It is a perfect square. So there is only one point where this is the tangent to this circle. There are no two solutions of this equation, right? Now let us come to the next question. It says, prove that in a parabola, semi-latus rectum is the harmonic mean of the segment of a focal chord. So if we take a focal chord and it is having focus a comma 0, one point is t1, another is t2, and it says that this particular segment L1 and this particular segment L2 length, so 1 by L1 plus 1 by L2, and half of that is equal to 1 by semi-latus rectum, that is 2a. So that means we have to prove 1 by L1 plus 1 by L2 is equal to 1 by a. So if we talk about L1, so what will happen? We will take L1 as root over a minus a t1 square whole square plus 2a t1 whole square, like this. And if we talk about L2, this will be root over a minus a t2 square, but we know that t1 t2 is equal to minus 1. So t1 is, this will become 1 by t1 square, and this is whole square, plus this will become minus 2a by t1 whole square, like this. Now if you take 1 by L1 plus 1 by L2, before that you can do some simplification. You can take a outside, and this will become 1 plus t1 to the power 4 minus 2 t1 square, and this will become plus 4 t1 square. So this will finally become 1 plus t1 square like this, after taking the root and square cancelled. And then we have made a perfect square here. Here again t1 square plus 1 minus 2 t1 square and 4 here. So what will happen? This will become again a into 1 plus t1 square, but one thing more, in the denominator you are going to get t1 square. Now when you will take 1 by L1 plus 1 by L2, so when you will take this reciprocal of this, so that means 1 by a 1 plus t1 square, and then you will take reciprocal of this, and then what will happen? A 1 plus t1 square in the denominator as the LCM, and 1 plus t1 square in the numerator. So it will get cancelled and you will get 1 by a, which you have to actually prove. Now let us come to the next question. Tangents are drawn from any point on the line x plus 4a equal to 0. Prove that their chord of contact will subtend a right angle at the vertex. So from x is equal to minus 4a, what is happening? That we are drawing the chord of contact. So what will be the chord of contact? y1 minus 2a x plus x1 is equal to 0. Point is x is equal to minus 4a. y1 is a variable point. So minus 2a x minus 4a is equal to 0. So this will become like this. Now this is intersecting the parabola y square is equal to 4x at 2 points. So at square comma t80 280 with those 2 points. One will be t1, another will be t2. Okay. So t1, t2. Now we are replacing here. So this will become y as 280 y1 minus 2a, and x will be 80 square minus 4a equal to 0. Now here, if we write it as a quadratic in t, what will happen? That it will become 2a square t square, right? And then we have minus 2a y1t, and then we have minus 8a square is equal to 0. Now you can cancel 2a like this, and it will become like this. Now in this equation, what will happen? That t is the parameter, and if you see that if you take this with the origin, then its slope will be, as this is at1 square comma 2at1, then its slope will be 2at1 by at1 square, which will be 2 by t1. Similarly for another point, this is the chord of contact. So another one will be 2 by t2. So we have the product of the slope m dash is equal to 4 by t1 t2. Now the product of the roots of this quadratic equation is c by a, which is minus 4a by a. So this is minus 4a by a. This is the product of the roots of this quadratic equation in t. So this will be minus 1, which means that product of the slope is minus 1, means these two lines are actually perpendicular to each other at the vertex. Let us come to the next question. It says from the point minus 1 comma 2, tangent lines are drawn to the parabola y square equal to 4x. Find the equation of chord of contact. Also find the area of the triangle formed by chord of contact and the tangents. So here we have the point minus 1 comma 2, and we have the parabola y square equal to 4x minus 1 comma 2 is this point. Find the equation of chord of contact, that will be 2y is equal to 2x minus 1. Also find the area of the triangle, so we can simplify it as x minus y minus 1 equal to 0. So this will be like this. So there are two tangents and this is the chord of contact. Also find the area of the triangle formed by chord of contact and the tangent. So let us find the perpendicular from here, P. What is its length? So P will be equal to minus 1 comma 2, so minus 1 and minus 2 and minus 1 mod by root over 2. So this will become 2 root 2. And then we have the length of this chord. So what will be the length of this chord? For that we have to find the extremities. So let us solve this equation and this equation. So y square will be equal to x minus 1 whole square, that will be x square plus 1 minus 2x, and that will become 4x. So this will become x square minus 6x plus 1 equal to 0. This will give you two values of, one is x1, another one is x2. So I am not solving further. From here you can find x1, x2, and then correspondingly you find y1, y2, and you find this length of this base, and then you can find the area of the triangle as half base into height, right? Or you can do some shortcut method here also, that you can do as you do the question. So students, that is all for this lecture. We will meet again in the next video lecture soon. Thank you all and keep working hard. All